Today, let's visit In-N-Out Burger and see how their drive-thru process operates. My goal is to compare In-N-Out drive-thru performance between off and peak hours. I found this graph on Google. It shows that the off hour is at 10:30 a.m. when business just opened, and peak hour at 12:30 a.m. when it's lunchtime. The drive-thru process can be modeled as a serial line. First, we have a take order queue, then a take payment queue, and next, a take food queue. Each queue consists of a waiting area and a service counter. These three queues made up of the drive-thru process. My method of gathering data is simple. I physically drive through during the off and peak hours. Then, I would analyze the footage using Apple's Final Cut Pro software. After each drive-thru, I will get out of my car, count the arrival rate while enjoying my burger. Let's take a look at the operation during the off hour. There are 2 cars in the order area, 1 car in the take payment area, and 2 cars in the take food area. Waiting is minimum, and every customer gets prompt service. Each customer can expect to spend about 9 minutes. The off hour has an arrival rate of 30 cars per hour. At this rate, the system has no bottlenecks. Let's then move to the operation at the peak hour. We can see the take order area has a pretty long line all the way to the other side of the street. The take payment area and take food area are also packed. Each customer can expect to spend about 18 minutes, twice the amount as the off hour. The peak hour has an arrival rate of 72 cars per hour. At this rate, while the service rate allows for more customers, I believe the bottleneck is actually the size of the waiting area. Let me show you what that means. When the line exceeds where this arrow is pointing, I saw potential customers leaving. There are many competitors in the area that also offers drive-thru service, so it's no surprising that people leave because the line is too long. In this case, I consider it a bottleneck because In-N-Out did lose business, and if the waiting area can be expanded, they can certainly serve more people. During my observation, I found 2 things that are very interesting. During the off hour, you take order at this counter at the middle of the drive-thru. During the peak hour, a staff member will walk towards your car holding an iPad, and he would take your order. Why is that? Let's map 2 locations on the map. Here is the off-hour counter. Here is the peak hour staff. I believe it is to take a customer's order early to prevent customers from leaving the long line. Think about it. If you wait too long, you get impatient and then you leave. You will be significantly less likely to leave if you have placed an order already. This is pretty genius. Another interesting find is that it takes longer to get your food during the off hour than the peak hour. At first glance, this makes 0 sense. How does it happen? As we know, In-N-Out operates a very standard menu with limited options. They can produce each item in bulk and just hand them out to the customers who order them. During the off hour, the restaurant just started, so it takes time for the staff to make the burgers. That's likely why I waited longer. At the peak hour, they already produced batches, so they probably just grabbed one off the line for me. Based on my analysis, the only way to break the bottleneck is to rerun the drive-thru so it can accommodate more cars waiting. But is it really possible? Probably not, given the layout of the UTC is already set, and the business also have to provide parking for walk-in customers. In conclusion, I think In-N-Out has achieved operation excellence based on my research. Thank you very much.